So a lot of this context is necessary for when we go into these kind of questions here. And then of course, when you get accustomed to seeing numbers like 729, 7 raised to the 3, which is 343, there are certain numbers where just by looking at them, you know what they're related to. Yeah? When a number ends with 6, chances are, unless it's 256, the number is related to 6. So for example, 36, 216, 1296, 7776, every power of 6 ends with a 6. Powers of 5 always end with a 5. 525, 125, 625. What come after that again? 525, 125, 625, 3125, then 15, 625. Yeah. 15, 625 after that. And then you just keep, you keep going up in powers, right? The 2s are related to the 4s and 8s. The 3s are related to the 9s and 27s. Yeah, and then the ones that they tend to give you are the powers of 7, the powers of 9, the powers of 3, 4, 5, and 6. Those are the ones that they usually give you. I mean, you really get the 11s and the 12s, rarely. Most of the time is between the powers of 2 to 9. Right? They really start going into like 12, 13, 11. I mean, they'll give you 11 raised to the 3, which is 1331. So, some of them not really that difficult. Yeah. Is there another set of rules beyond this that I need to show? No, I think I showed everything. Because you have the square, you have the square root. So it's for us. Oh, you know what? So just imagine that this square root is the same as this. One over 2. Imagine that this cube root is the same as our 1 over 3. And then of course everything makes sense. So if we were to rub this out, we get rid of that 3, we get rid of that 2. Yeah. So that would make everything make sense. So you can remember all of those indices rules, and of course matching your, and then of course you can go back in the opposite direction. So when you start go 3 to the minus 1, 1 over 3, then 1 over 9, 1 over 27, 1 over 81, 1 over 243, 1 over that. Right? So you just know. To the minus 1, 1 over this. To the minus 2, 1 over that. Minus 3, 1 over that. Minus 4, 1 over that. Yeah, so that's yeah. There, let me see if I can find that question. Because maybe if I show that question now, it would make more sense. Yeah, I'm looking for it. What? Oh. Oh, that's it? Okay, hold on. Let me go in the other direction now. There was one that I saw. No, I don't want that. Alright. I didn't want to do this one, but since that's what I have in front of me, I'll work with it. Alright. So let me do this real quick. Because, you know, what we did a while ago was a harder version of some of those questions. So let's go into this. So let's see what we're going for this now. It says 9 raised to the 4x plus 5, right? Is equal to 729 multiplied by 81 raised to the x minus 2. So there's a lot to unpack there, right? Now, I know that this is 3 raised to the 6 based on what we did before. So we know that. This is 3 raised to the 4, which is being multiplied by x minus 2. So that's going to be just on this side alone, 3 raised to the 4x minus 8. Now, based on our rules of indices, let us say we have 3 to the 6 times 3 to the 2. It means we have 3 to the 6 plus 2, resulting in 3 to the 8. Now, for context, it means we're going to add 6 plus 4x minus 8. So if I were to remove this and do this, yeah, that is exactly what would be taking place, right? Now 6 minus 8 is minus 2. Therefore, when we're done with this, we'll end up with 3 raised to the 4x minus 2. Alright, so we're done with the right side. Now over here, we have what? 3 raised to the 2, 4x plus 5. This is 3 raised to the 8, x plus 10. Now let's look at exponents carefully. This is 8x plus 10. This is 4x minus 2. Alright, so now we forget about the bases. 8x plus 10 equal 4x minus 2. We minus 10 from both sides. So that's what now? 4x minus 12 on this side. And then we just have this. Now we're going to minus 4x from both sides. So we're going to have this. Now we will have 4x is equal to minus 12.